Hello, everyone. My name is Vitek Bedek. I work at Fujitsu in Munich, Germany, and I will give you an update on the Monasca project. Although it's not the first presentation for me, I have already presented about Monasca a couple of times, but it's the first one for me as the project team lead. So, what is Monasca? The abbreviation MONAS stands for Monitoring as a Service, and we have added logging to this, so the full name is Monitoring and Logging as a Service. Monasca is designed as microservices message bus-based architecture. I will explain in the next slide what I mean by that. It implements push-based metrics model, meaning the agent sends the metrics to the API, as opposed to the pull model, like for example by Prometheus, where the metrics are requested pulled. For monitoring as a service, push model is a preferred one. You avoid some issues with networking. You can cache some metrics in the agent if the service is not available for some time. Monasca is designed for elastic cloud environments. So in cloud environments, you can add services. You add new nodes, delete the nodes, and the monitoring system has to couple. This has to be designed to cope with this. Monasca is designed for high availability. It is horizontally and vertically scalable. It's capable of long-term data retention. So if you're interested only on operational modeling, it's perhaps not that important for you. But there are other use cases, like if you have SLA metrics, or you use your monitoring system for capacity planning, trend analysis, you're interested in historical data. So it's important to have long-term data retention. And in Monasca, we are able to store the metrics for retention periods of 1 year and more. Monasca is extensible and composable. And with extensible, I mean internally extensible. You can add modules, add microservices to implement the specific task. And in this way, you extend the system. Our architecture. We have the agent, which collects the measurements and sends to the API. The API sends the measurements and logs to the message queue, to Kafka. And these components below are microservices which work independently of each other. Each of them accomplishes a specific task. So we have a persister, which stores the measurements in the measurements database, which is InfluxDB. We have transform engine. I will talk about this one later. We have threshold engine, which evaluates alarm expressions and generates alarm state transition messages, which are then sent back to Kafka. We have notification engine, which is responsible for sending notifications to the users. And the key component is Kafka. All the microservices communicate with each other through the message queue. The messages in Kafka are organized in topics. So the metrics are published to topics in Kafka. The microservices, they register in Kafka consumer groups, and subscribe to these topics. They consume the messages from the topics. Kafka Consumer Group is responsible for replication and for load balancing of messages. So messages are replicated per consumer group. You can have more than one. And the messages are load balanced across all consumers in the consumer group. So for example, if you have 3 persisters registered in one consumer group, all messages from the topic will be load balanced between, will be evenly distributed between these persisters. Around Boston Summit, we have asked Monasca users and operators to fill out the monitoring survey, and we have asked about monitoring tools and also satisfaction on using Monasca. And these are the results. So you can see many where it's like 2/3 of questioned users and operators were not satisfied with installation. Also, documentation was not that good. We have quite some documentation, but it's spread between different places. We also lack good installation documentation. Configuration is much better already. Operation, quite good. But you can notice installation is our pain point. And to address these pain points, we started the effort of containerizing Monasca. It's actually perfectly suited because of its microservices architecture. So you can containerize all the components in this Monasca Docker repository. We provide production-ready Docker images and also Docker Compose files, which are used for easily building and running the complete Monasca deployment. Monasca Docker repository is perfectly suited for development purposes, so it makes development much easier than traditionally with a DevStack setup. You can easily build your own container with the code you're testing, deploy it and test. The second repository is Monasca Helm. It contains Helm charts for Monasca deployment in Kubernetes cluster. Can be considered as production ready deployment in the cluster. The one component I have mentioned in the architecture is Monasca Transform. Has been introduced in Okata release. Its task is to read the messages from read the measurements from the message queue and transform and aggregate them to create new metrics. What are the use cases? One would be to aggregate individual metrics, like you have, for example, memory between different VMs, and you want to have total aggregated memory used across all the VMs. Another use case would be to combine different metrics and derive a new one. Like, for example, you have a metric with total logical cores used and idle CPU percentage, and combining these two metrics, you can generate a new one, which describes the CPU utilization across the nodes. And the third important use case is, for example, calculating some functions like rate of change of a given metrics. We want to see how it changes in time. The implementation is based on Apache Spark streaming. The metrics are aggregated and published every hour. But there were some problems. There are some problems with the Monasca transform engine. One of them is it is based on Apache Spark, which is difficult to deploy and to operate. Also, due to the way how Apache Spark operates, it works on batches. So it collects all the metrics at once and makes calculations on them, and then returns the result. It caused large CPU peaks during the operation. And it was, especially in the Kubernetes environment, it was very problematic with Apache Spark deployment and the memory and CPU consumption. So another component was started, Monasca Aggregator, which addresses these issues. It generates continuously new real-time aggregations. It supports aggregation functions like max, min, average, rate of change, difference. It has a simple expressive language for defining the aggregations. It is implemented in Go. The downside compared to Monasca Transform is the computation is not performed in a distributed way as it is in case of Apache Spark, Monasca Transform and Apache Spark. Here is the use case, how you could use the aggregated metrics for alerting. So on this graph, you have the time axis and available space on the disk. We have two use cases. The green line shows traditionally we would have a fixed threshold, like for example 10% of the disk space, and in the first use case we just have disk usage of, let's say, 11%, and then it goes slowly down to 9%. So the threshold will be reached and the alarm will be launched, although the disk space remains stable. So actually there was no need to alarm. And another case is we have a lot of available space, but now at some point there is something is writing to the disk and it drops down, but we still don't know anything about it until it reaches the 10% mark, and then we have no time to react. So how we can handle this? We can make our alarm definition with the rate of change metric aggregated with a new component. So we check how fast the metric changes. And in this case, the green line will not launch an alarm because the threshold is set much higher. And the second one will launch the alarm because the rate of change has been exceeded. Another new feature, it is still in development, comes probably in Queen's alerting manager. So in the monitoring system, you want to have monitoring data and alerts for everything which you can measure. But on the other hand, you don't want to be you don't want to be spammed with the alarms. You want only have meaningful alarms. And that's where the alarming manager comes. So what are its functionalities? The first one is grouping. So as you have seen in the example I have just shown, you can have several different alarms actually addressing the same problem. So you So you probably want to group them, so you only won't have one notification and saying which threshold exactly have been exceeded. The second functionality is silencing. It addresses the use case when, for example, due to maintenance period, you know there will be some alarms, but you're not really interested. You know that these alarm definitions will launch, so you silence them. And the third one is alarm inhibition. So it is meant for correlating alarms when you have one big issue with which, let's say you have MySQL database which is not available. Of course, many other services are dependent on this, and all of these services you want to measure as well. So you will have like tens of alarms, but you know the most important one is MySQL alarm. So you want to inhibit all the others. You want just one MySQL alarm and not the others. The change is in good progress and should be landed in Queens. Another Queens priority for us is a time series database alternative to InfluxDB. InfluxDB is probably the best open source time series database, and we have support for this. But the clustering in InfluxDB is closed source, so we look for the alternative, which is open source. Target is to get 50 billion measurements, 200 million metrics, which corresponds to the deployment of around 200 compute nodes and 8,000 VMs. It is the reference system for which we do the test measurements. Why we have chosen Cassandra? Because it's a very mature database. It scales very well. It has many deployments. It's easy to set up and maintain. There are some problems with it, but all of them require some programming. We have a team who works on this, and I hope they will find solutions for this. The change is also well in progress. I hope it will be landed in Queens. Another new feature is service domain for tenant agents. So the use case is we want to monitor guest VMs. We want to install agent on the VM. And when we install the agent, we have to store also credentials for the agent user. It will be stored on the VM where the OpenStack user has access to. So there is a high risk that these credentials will be compromised. With these credentials, in the default OpenStack deployment, the user will get quite wide privileges, and it is a big security risk. So one way to cope with this would be to define policies for all other services so that the user cannot launch new instances, cannot add and delete volumes and stuff like this. But in many cases, it will not be the case. So we came up with the idea of defining a dedicated keystone domain, which defines the administrative boundaries where the agent user will be created. And the Monasca API will create the mapping between this agent user and the actual project for which the metrics are. Monasca events. The vision of Monasca is to correlate different sources of information, so measurements and logs. We have, to some extent already, what is missing is events. And the first step to accomplish this is to persist OpenStack notifications. We have already started with creating Monasca Events API and extending Monasca Persister to store the events in Elasticsearch. Yeah, so that's the first step to realize this vision of Monasca events. The patches are in progress. Cross-project work. We don't have much cross-project, but there is one project we have integrated lately. It's CloudKitty. CloudKitty is rating as a service. So basically translates metrics to prices, how you charge your users for using OpenStack. And initially, CloudKitty has collected data from Silometer and then Gnocchi. In Quinn's release, they have added a collector for Monasca, so now you can query the measurements from Monasca to use it for billing in CloudKitty. The change is already implemented. How can you contribute? How can you give us feedback? You can write us at OpenStack Monasca in IRC channel. We also have weekly team meetings, Wednesdays at 2 p.m. UTC. How to contribute? We need reviewers. You can contribute by fixing bugs. We have a work list in Storyboard with open bugs. We need support by completing community-wide goals. We still are not ready with bike community goals. If you want, you can contribute by developing installers, like, for example, contributing Monasca to Cola or OpenStack Ansible installers. We also want to work on documentation, and your contribution will be very welcome there. And of course, any other regions, we are welcome for contributors. One slide for my wife. I love you. Questions?
On the service domain work that you guys are doing, we're going to do some kind of enhancement on the horizon part as well, so that, for example, tenants could just see the metrics on their project.
So the question was about the Keystone domain extension I have presented, and
I was asking more about the visualization just for the tenant itself, if that is
all right. We didn't think of it. What we thought about was in Horizon is like for automatic credentials generation for the agent, or also using hit template to deploy the agent on the guest VM. And what you're interested is implementing graphs in Horizon for tenant metrics, right? Did I understand correctly?
I was thinking more like metrics as a service, if you want to expose it to the tenant.
Yeah, well, you basically can do this already. I mean, not in the Horizon directly, but in Grafana, right?
Okay.
Mm-hmm.
All right. I'll check it out.
So you just mentioned the containerized Monasca, so which means I can use the container technology to store in production ready Monasca file customer.
I didn't fully understand, so we asked about.
For now, I can use container technology to deploy the Monasca project, right?
Yes, right. So
all the images are ready to use.
So the question was how ready the images in Monasca Docker repository are. we are in the phase of stabilizing. So we have created stable branches, but we are still working on configuration for the stable branch. Yeah. I wouldn't describe it as production ready, but it is a goal, and we are not far away from this. Okay. There are no more questions. Thank you.